the noise pollution monitoring, due to growing urban development, noise levels in cities have increases and even become high in some cities. IoT-based noise pollution monitoring system, it is used to noise monitoring system that are deployed at different places in a city. The data on noise level from the station is collected on server on the cloud. The collection of data, the aggregator generate noise maps. Okay, then next is forest fire detection. Okay, what is the forest fire detection means? It can cause damage to natural resources, property and human life. Early detection of forest fire can help in minimize damage. The next one is river flood detection. It can cause damage to natural and human resources and human life. Early warnings of floods and given by monitoring the water level and flow of water. They are all the IoT based river flood. The monitoring system uses a number of sensors, nodes that monitor the water level and flow rate sensors. Then next is energy. The energy domain has three: smart grids, renewable energy system, prognostics. What is energy? Either it is a data communication network between integrated with the electrical grids that collects and analyze data captured in near real time about power transmission, distribution, and consumption also. Then smart grid technology provides predictive information and recommendation to utilities, their suppliers and their customers, and how best to manage the power. By using the IoT based sensing measurement technologies, health of equipment, integrity of the grid can be evaluated. The next topic is renewable energy system. IoT based integrated with the transforms at the point to interconnection, measure the electrical variables and how much power of field into the grid. For example, the wind energy system, okay, closed loop controls can be used to regulate the voltage at point to interconnection, which coordinates wind turbine outputs and provides power support. Then next topic is prognostics. In the system such as power grids, and real-time information is collected using specialized electrical sensors and PMU at the substations. The information received from PMU must be monitored in real time of estimating the state of the system for the predicting failure. What is the predicting? Predicting failure means we have invention of any IoT devices. Okay, it is the one of the invention. Okay, then next, retail. Retail application has three points: inventory management, smart payments, and smart vending machines. First, inventory management. IoT system enable remote monitoring of inventory using data collected by RFID readers. Then next is smart payment. It is solutions such as contactless payments powered by technologies such as near field communication. Near field communication is a short form of NFC and Bluetooth also. Then next is smart vending machines. Sensors in a smart vending machines monitors its operation and send the data to cloud, which can be used for predictive maintenance. Okay. Then next, logistics. Logistics domain have 4 points. The first one is route generation and scheduling. Mostly we will use it to route generation and scheduling. We will use a train or a long travel bus and trucks. Okay. Then second point is fleet tracking. Then third point is shipment monitoring. Fourth point is remote vehicle diagnostics. See the picture of logistics. Okay. Mostly we will use long travel devices of the system. First, route generation and scheduling. IoT based system backed by cloud can provide first response to the route generation queries and can be scaled up to serve a large transportation network. Mostly we will use logistic transportation purpose. Then next, second point is fleet tracking. Fleet tracking, we will use GPS to track location of vehicle real time. Okay. Then next, third point is shipment monitoring. IoT based shipment monitoring system use sensors such as temperature, humidity, okay, it to the monitor of conditions and send data to cloud where it can be analyzed the defect spoilage, detect food spoilage. Then next, fourth point is remote vehicle diagnostics. System can be used on board IoT device for collecting data on vehicle operation, speed, RPM, then etc. and status of various vehicle subsystems. Then seventh one is agriculture. We will use the IoT in agriculture, smart irrigation, greenhouse control. Okay, see the diagram. Smart irrigation. Mostly we will use the mobile. Switch on the motor, switch on the power supply. Okay. Then first point is smart irrigation. To determine moisture wet amount in soil. Okay. It is the diagram of smart irrigation. Then second point is greenhouse control. Greenhouse control means it is improve productivity. Okay. Then next is industry. We have 2 points. Okay. Machine diagnosis and prognosis. And last point is indoor air quality monitoring. First, application of industry domain as an industry domain. Machine diagnosis and prognosis. See the diagram. Indoor air quality monitoring, the second point. Then next, health and lifestyle. They have 2 points: health and fitness monitoring, wearable electronics. Then first point, health and fitness monitoring. You see the diagram. If you have smart watch or smart mobile phones, or through the internet to connect the system using IoT. Then next, IoT system comprises of following works. What are the applications? The applications, device, resources. What are the workings? Device, resources, controller service, database, web service, analysis component, and also applications. Device. For the device, it is a remote sensing, actuating, and remote monitoring capabilities. We will learn the various example of IoT devices. Okay, then next is resource. We are software components on the IoT device for assessing, processing, and storing sensor information, or controlling actuators to connect it to the device. Okay. Resource also included the software components that enable network access for the device. Then next third point is controller service. Controller service is a native service, okay, that runs on the device and interacts with the web service. The control service send the data from the device to the web service and receive commands from the application through to via web services, okay, for containing the devices. Then next is databases. Database can be either local or in the cloud and stores and the data generated by the IoT device. Then next fourth point is web service. It is a link between the IoT device, application, database, and analysis components. It can be either implemented HTTP and REST. Okay, the principles of REST services using the WebSocket protocol. Okay, then next analysis components. It is responsible for analyzing the IoT data and generate result in a form which are easy for the user to understand. Okay, then next applications. IoT application provide an interface user can to interface that the user can be easily used. Okay, they have 6 levels of IoT: level 1, level 2, level 3, level 4, level 5, level 6. See the diagram, totally 6 levels. Then the first level, level 1 IoT system has single node device that performs sensing and actuation, store data, performs analysis and host the application. It are suitable modeling low cost. It is a low cost and low complexity solution where the data involved is not big and analysis requirement are not intensive. Then next, second level, it has a single node that performs sensing and or actuation and local analysis. It data stored in cloud and application is usually cloud based. IoT system are suitable for a solution where the data involved is bigger. Then next, level 3, it has a single node, data stored and analyzed. The cloud and application is cloud based. IoT system are suitable for solution where the data involved is big and the analysis requirement are computationally intensive. Then next, fourth level, we will see fourth level. What is the change for the 3 levels? The 3 levels have only single node, but the fourth level have multiple nodes. Okay, see the diagram. It perform local analysis. It is stored the cloud and application cloud based. Okay, it contain local cloud based observer nodes which can be subscribed and to and receive information collected in the cloud from IoT devices. The system are suitable solution where multiple nodes are required. Then they have morely one or more control services they will available of IoT level 4. Then next we will see IoT level 5. The level of 5 system has a this also multiple end nodes and one coordinator nodes. Okay, see the difference. That IoT level 4 only have multiple nodes. Okay, but level 5 is multiple and end node, multiple end node and one coordinator node will join. Okay, the end node that perform sensing and actuation. The coordinator node collects the data from the end nodes and send it to the cloud. Okay, data is stored and analyzed in the cloud and application is cloud based. The suitable solution based on wireless sensor network in which the data involved a big and the analysis requirement or computationally intensive. Then next, the last level, Okay, last level of IoT is level 6. The system is this also multiple independent end node. Okay, what is the difference of IoT level 5 and level 6 means they have multiple node and multiple end node and the one correspondent node, but the IoT level 6 has multiple independent end node that perform sensing and actuation and send data to the cloud. It is stored cloud and application is cloud based. The analytics component analysis the data and stores the result in the cloud database. There are result are visualized with the cloud based application. The centralized control is aware of the status end node sends control commands. Okay, thank you to all.